All right, so at first glance, question 7 kind of looks a little bit different, the wording of the question at least. So I would like you to put some thought into why is this statement here? Sometimes math questions have these built into the questions, but and then we just don't talk about them. We don't know why they're there. So think about that for a second and then unpause the video and see if you came up with the same thing as me. Okay, so for this, since you have a 1 over p, p can't be equal to 0 because then you would have division by 0. So we're going to make sure that p is bigger than 0 but not equal to it. And then likewise, if p could be equal to 50, then this would go to 0, and then we would have division by 0 there. So we don't want to equal 50. So we need the numbers in between. I don't want numbers equal to 0, so I want to stay on to the right of that. I want numbers less than 50, so that's where that inequality is trying to say there. But antiderivative is just another way to say integrate. This would need to be dp, because we don't have x's, so no point in putting those in there. And so now it looks like the questions that we have been doing here. So I'm going to say I'm going to use algebra to make this fraction look like this fraction. So one factor, second factor, two fractions. Of course, if it has three fractions, you could do, or I'm sorry, three factors, you could have three fractions. We saw that in a previous question. Okay, now if I go through and multiply everything by p, this cancels out this cancels out this. These two do not cancel out, so that will be bp. I would like to multiply everything by 50 minus p. That makes these cancel and these cancel, but these stay around. So that is like a times 50 minus p. And both of those canceled, so it still just equals 1. Okay, so if I want the b values to go away, I could temporarily plug in p equals 0. And so when I do that, I get 1 equals 50a, therefore a must be 1/50th. Or I could set p equal to 50, which makes the a's go to 0, and that would leave me 1 equals 50b, and therefore b is 1/50th. Now, hopefully you've worked enough questions at this point to know that that's just a coincidence. It doesn't have to happen. These a and b values are not usually the same. Don't assume they're the same. Don't just do one and assume the other one's the same thing. That just happens to be with this case. So then I'm going back to this up here. So instead of saying this fraction, I just figured out what it's equivalent to. So I'm going to split this into two integrals, just like this is two fractions. So I've got a went over p. So a over p. And then I have a b over 50 minus p. That's just how I defined a and b up here, so when I solve for a and b, that's where they need to get plugged in. Okay, and then we should just be about finished. Now, again, these constants, most people like to just kind of pull these out front and worry about them after the integration. I think both of these are easy enough that you probably don't feel like you have to pull them out as a step, but feel free to if you need to. So my answer is 1/50th of this antiderivative, which we memorize, plus 1/50th of this antiderivative. And of course there should be a plus c. Now once again, I created a mistake in here and kind of breezed past it. I wanted to give you a chance to see if you could figure it out. And I'll be honest, this one's a little harder to see. This would be one of the most common mistakes if this was on the test. Of course, it's not the plus c like I did to you in the previous question, but there's still one more thing here. So Give yourself a minute or two, pause the video, see if you can find that in a minute or two, and then unpause. Okay, so the problem is, where I have a mistake here, is remember we are finding the antiderivative, which means you can check your answer by taking the derivative. If I take the derivative of this, I get 1 over 50 times 1 over p. Exactly what I wanted. If I take the derivative of a constant, I get 0. Of course, there always could be a plus 0 there, so that's fine as well. The problem occurred right here. If I take the derivative of this to test it, I get 1 over 50 times this derivative, which would be 1 over 50 minus p, and then because of chain rule, times the derivative of the inside, times a negative 1. So this isn't supposed to be negative, but I'm creating a negative. So the long way to do it, that turns it into a process if you don't want to do it in your head, is use substitution. I can see that it's going to create a negative 1 that I don't want. So if I simply multiply that by a negative, that will balance that out. So there is one possible answer, and then looking at the solution guide, we need to practice when our answers look different here so that we're so that we feel like we can do this on multiple choice questions. But with logarithms, typically if you have an exponent on something you're taking the log of, you can bring that down out front, but you're welcome to go the other direction. So pull up the 1 over 50 on both of those. And then to get the other answer in the solutions, notice this is a natural log minus a natural log. So if those are the same type, we can condense those natural logs into a division. We can condense subtraction into division. First part is the numerator. Second part is the denominator. And if you'd rather, this is absolute value and this is absolute value, so this is guaranteed to be positive and this is guaranteed to be positive, it just means that this whole thing is guaranteed to be positive. This last line isn't really better in my opinion, but just a little bit different. So that would be fine too.